This series focuses on data structures and algorithms content, and particularly in this recording I will talk the first part 1 of bubble sort algorithm. The second and third parts will present coding and analysis of this algorithm. Suppose we have these elements or data items in an array or linked list with the element values equals to 18, 6, 3, 12, 9, 36, 21 and 15. And suppose we want to arrange these elements in ascending order or increasing order of their values, and we want to use a bubble sort algorithm for this purpose. This algorithm operates by first putting all the elements under consideration. Here the green rectangle surrounds all the elements currently being considered. For these considered elements, the bubble sort algorithm processes each pair of the elements starting from the left to right, and from among the elements currently being considered, that is from among the elements within the green colored rectangle, we select the first and second elements with values 18 and 6, which are surrounded by orange colored rectangle. We check whether the left side element or the first element is smaller than the second or right side element. In this case, this is not true or it is false. The left side element is not less than the right side element, and the decision of our algorithm would be to swap these values. And after swapping, here we make sure that the larger element comes after the smaller element. That means 18 is placed after 6. Now after this, our attention moves to the next pair of elements, 18 and 3, and again we follow the same process. We compare the elements and see whether this comparison turns out to be true or false. In this case it is false, and the action we take is swap again. After swapping, the larger element is placed after the smaller element, 18 after 3, and again we follow the same process. Our attention shifts to the next pair of elements, 18 and 12, and we compare again, and we find that this is also not true. We decide to swap, and swapping process will actually place 18 after 12. Then our attention moves to the next pair, 18 and 9, and again we compare, which is false again. 18 is not smaller than 9, and we make a decision to swap. After swapping, 18 comes after 9, and attention moves on to next pair. We compare. Now in this case, the result of comparison is true. The first element is smaller than the second element, 36, and therefore our decision is no swap. We don't swap. Now our attention moves on to the next pair. We do comparison, and the result of comparison is false, not true. Then we decide to swap again. Then our attention moves to the next pair, and again we do compare. We find that the result of comparison is not true, it is false. Then we decide to swap. After swapping, the largest element amongst all the elements being considered actually is placed at the rightmost position. Now the purpose of our algorithm is to arrange these elements so that they are in increasing order, in which case the largest element should go to the rightmost position. So this is in this case, after this stage, we actually don't want to toss this 36 value. We want it to be fixed or locked. So this is locked now, and now comes the second pass. In the second pass, only the elements in the green rectangle now here are under consideration. We don't consider 36 anymore for the sorting purpose. Now again our attention moves to the first pair of elements. We compare whether 6 is less than 3, which is false, and we decide to swap. And our attention moves on to the next pair of elements and compare, which turns out to be true, and we decide not to swap. Attention moves to the next pair of elements, we compare, and comparison result is false, so we decide to swap. And attention shifts to the next pair of elements, we compare, and the result turns out to be true, we decide no swap. And our attention moves on to the next pair, we do compare, the result turns out to be true, so we do not swap. And next comparison, the result of comparison is false, so we decide to swap. Now at this point you can see the largest element amongst the elements being currently considered is 21, which is placed on the rightmost position. We again do lock this element. Now in this third pass, again our attention moves to goes to the first two elements, and we compare, we find it to be true, we decide not to swap. Again we move our attention to the next pair, we do compare, and we find it to be true, we decide no swap. And attention moves to the next pair, we do compare, and we find it is true, we decide not to swap. Our attention moves to the next pair, we compare, we find it to be true, we decide no swap. And again we focus our attention to the next pair of elements, we compare, now it is false, so we want to actually do the swapping. Now at this point, if you look into all the elements, they are actually placed in the sorted order, and at this point we may not need to continue further processing. Actually that is something that is implemented by efficient kind of the bubble sort algorithm, but in this case I am going to follow all the iteration. Theoretically we have to follow all the iterations. So now at this point this rightmost element is the largest, and we have to lock this element. And in the next pass, again we focus our attention to the first two elements, we do compare, and we find it to be true, we decide no swap. Focus on the next element 6 and 9, we compare, we find it to be true, we decide no swap. And attention shifts to the next pair of elements, we compare, find it to be true, no swap. Attention shifts to the next pair of elements, we compare, we find it to be true, no swap. And at this stage we have to lock the rightmost element which is being considered. Now the elements under considerations are 3, 6, 9 and 12, and again we have attention on the first pair of elements, we do compare, we find it to be true, we decide no swap. Attention shifts to the next pair of elements, we do compare, find it to be true, we decide no swap. Attention shifts to the next pair of elements, we do compare, we find it to be true, no swap. And at this stage we need to lock the element on the rightmost side. Again the same process, elements under consideration are 3, 6 and 9. We focus our attention to the first pair of elements, we compare, we find the result of comparison to be true, we decide no swap. Our attention shifts to the next pair of elements, we compare, and we find the result of comparison to be true, and we decide no swap. Now at this point we lock the value 9, and we have only two elements under consideration. Attention shifts to those two elements, we do compare, we find it to be true, we decide not to swap. Now we have only one element, and we don't have anything to compare with. We need to have at least two elements to compare, so automatically the algorithm will terminate at this point, and it will actually 3 can be seen as a locked element. So we have all the elements placed in the increasing order of their amplitude. That means all the elements are actually now sorted in ascending order. So this is all I have to talk about the this concept of bubble sort algorithm. In the next recording of this series, data structure and algorithms, I will show how to code a bubble sort algorithm in C++. Thank you for watching this video.